Welcome back to the deep dive. Our mission here is always to dig into the sources, find that crucial, sometimes hidden knowledge you need. And today we're tackling something really vital in fertility management, but often uh, missed. It's about the genetic material itself. If you, or maybe someone you know, have faced things like recurrent miscarriage or IVF cycles that just didn't work, even when the standard tests look fine, well, this conversation is for you. We're diving deep into sperm DNA fragmentation, or SDF. Seriously, this might be the piece that's been missing.
It really might. It's actually quite startling how often high SDF comes up, but it gets overlooked in those initial checks. For so long, the focus was just on, sperm count, how they swim, things you see under a microscope.
Right, the basic.
Exactly. But what the research we're looking at clearly shows is that the quality of the genetic stuff, the DNA, the sperm carry, that's just paramount. And the good news, it's something we can measure, and often it's very responsive to intervention.
So there's hope.
Definitely. This knowledge could genuinely be the missing piece of the puzzle you've been searching for. It might open up a path forward where maybe other treatments haven't succeeded.
Okay, let's unpack this then. SDF.
Yeah.
What are we actually talking about in simple terms?
Right. So SDF, sperm DNA fragmentation, it means the genetic material, the DNA packed inside the head of the sperm cell, is damaged. It's broken into pieces.
Like broken instructions.
Exactly like that. Think of it as the blueprint for a new life having torn pages or smudged lines. A high level of SDF means lots of sperm are carrying these faulty instructions.
And that damage, it causes problems after fertilization.
Yeah.
Even if the sperm reaches the egg.
Precisely. That's a key misunderstanding. Just because a sperm can swim and fertilize doesn't mean it's carrying healthy DNA. Fertilization might happen, yes. But that DNA is crucial for everything that comes next, guiding cell division, the very first steps of development. So when that DNA is heavily fragmented, the embryo that results often struggles. You might see it growing really slowly or just stops developing after a few days, fails to reach that important blastocyst stage.
Which means it won't implant.
Or it fails to implant properly in the uterine lining. And in the worst cases, it can directly lead to early miscarriage, sometimes recurrent miscarriages. That genetic code's integrity. It's literally the difference between a viable pregnancy and, well, a heartbreaking outcome.
So how do we measure this? It's not visible, right?
Not with standard tests, no. We need specialized tests that measure something called the DNA Fragmentation Index, or DFI.
DFI.
Yeah, and the DFI is basically the percentage of sperm in a given sample that have this damaged DNA.
Are there clear levels, like good versus bad?
There are thresholds, yes. The sources are pretty consistent here.
Yeah.
Generally, a DFI below 15% is considered normal, sort of the lowest risk zone.
And the problem zone.
Well, once you get above 30% DFI, that's generally seen as a significant issue. That's where the risk for failed treatments like IVF and miscarriage really starts to climb. Clinical intervention is usually recommended then.
What about that middle ground? Say between 15% and 30%.
That's where things get a bit more nuanced. It's really interesting.
How so?
In that intermediate range, the impact seems to depend quite a bit on the female partner's egg quality.
Really? The egg can compensate?
To some extent, yes. You see, the egg actually has its own repair mechanisms, enzymes that can try to fix some level of sperm DNA damage right after fertilization. Younger, healthier eggs are generally better at this. Think of them like a really efficient repair shop.
Yep.
So they might be able to handle sperm with DFI in that, say, 15% to 30% range. But as egg quality naturally declines with age, especially for women maybe over 37 or so, that repair capacity weakens.
I see.
So a DFI of, let's say, 22% might not be a major barrier for a couple where the woman is 30, but it could be the very reason for implantation failure if she's 40.
That makes sense. It highlights why checking SDF is so important, especially if advanced maternal age is also a factor.
Exactly. It's an interaction.
Okay, this brings up a really important question, especially about treatments like IVF or ICSI. People often think these advanced technologies kind of bypass sperm problems. So why doesn't ICSI just fix this SPF issue? You're literally injecting the sperm into the egg.
That is such a critical point and honestly a common misconception. It's vital to understand what ICSI actually does.
Okay.
What's fascinating here is that ICSI is brilliant for overcoming physical problems. Low sperm count, no problem. Sperm that don't swim well. ICSI bypasses that because an embryologist selects a sperm and injects it directly.
Right, it gets it there.
It gets it there. But ICSI is just a delivery method. It does nothing, absolutely nothing, to repair the genetic cargo inside that sperm. If the DNA is already broken, ICSI delivers broken DNA.
So you're still starting with damaged goods, essentially.
Precisely. No matter how advanced the procedure, it can't magically fix fragmented DNA once it's inside the egg. That's why high SDF can still lead to poor embryo development, failed cycles, and miscarriage, even with ICSI.
Okay, that's a huge clarification. So if the problem isn't just getting the sperm there, but the DNA itself, we need to look at why the DNA gets damaged in the first place. The sources point to something called oxidative stress.
Oxidative stress, yes, that's really the key biological villain here.
Explain that a bit.
Sure. Think of it as an imbalance in the body. You have these molecules called free radicals, or reactive oxygen species. They're like tiny, unstable agents that can damage cells. And then you have antioxidants, which neutralize them. Oxidative stress happens when there are too many free radicals and not enough antioxidants to handle them.
Like biological rust.
That's a great analogy. Yes, it's like these free radicals are trying to rust sensitive parts of the cell, including the DNA.
And sperm are particularly vulnerable.
Uniquely vulnerable, actually. Here's where it gets really interesting. Sperm cells are designed for speed and delivery. They've shed most of their cytoplasm, the cell's main body, to be streamlined.
Oh.
But that cytoplasm is usually where a lot of the cell's protective antioxidants are stored. So sperm have very little internal defense against this oxidative damage. While they're maturing and being stored, their DNA is left quite exposed.
Wow. Okay, so what causes this oxidative stress? What are the drivers we should know about?
Right, let's get into the actionable stuff. The sources identify several key categories of things that ramp up oxidative stress and damage sperm DNA.
Let's list them out. Lifestyle seems like a big one.
Huge. Smoking is a major one. It just floods the body with free radicals. Heavy alcohol use, recreational drugs too.
Yeah.
Then there's chronic stress, not getting enough sleep, being significantly overweight, or having a diet that's poor in antioxidants.
Yeah.
Not enough fruits and vegetables.
Okay, standard health advice, but critical here. What else?
Then you have specific medical issues or environmental factors. Things like infections or inflammation, particularly in the prostate or testicles, they generate a lot of oxidative stress locally.
Makes sense.
And we absolutely have to mention varicocele.
Varicocele, remind us what that is.
Sure, it's basically like varicose veins, but around the testicle. These enlarged veins let blood pool, which raises the temperature locally and increases oxidative stress right where sperm are developing. It's a very common cause of male infertility and high SDF.
Right. Heat seems to be a recurring theme.
It is. Direct heat exposure is another big factor. Frequent use of saunas, hot tubs, even wearing really tight underwear that traps heat close to the body.
Laptops on the lap.
Yes, that too.
Right.
Prolonged heat exposure from a laptop. Also, exposure to certain environmental toxins or radiation can contribute. Basically, anything that raises the scrotal temperature can accelerate DNA damage.
Okay. And what about age?
Age is definitely a factor. As men get older, particularly, say, past 40, the body's natural antioxidant defenses tend to decline a bit. And the cumulative effect of oxidative stress means DNA damage can increase. So DFI often trends upwards with age.
Got it.
Yeah.
Before we talk solutions, you mentioned specialized tests earlier, like SCSA, 2NL, COMET assay. Why are these needed on top of a regular semen analysis?
Great question. It's about what they measure. A standard semen analysis looks at the outside. How many sperm are there? How well do they swim? What do they look like? It's morphology, motility, count.
Yeah, okay.
But these specialized DFI tests, SCSA, 2NL, COMET, they look inside. They use different techniques, often involving dyes or electrophoresis, to assess the actual integrity of the DNA within the sperm head. They measure how much breakage there is.
So they reveal this hidden damage.
Exactly. If you're facing unexplained infertility or recurrent failures, especially if the standard semen analysis looks okay, pushing for one of these DFI tests is often the crucial next diagnostic step. It tells you about the quality of the blueprint itself.
Okay, this sounds potentially daunting, but you mentioned earlier that it's often manageable. That's the good news, right?
That is the really encouraging part from our sources. High SDF isn't necessarily a permanent sentence. Because oxidative stress is the main driver for many cases, we can often reduce it significantly by tackling those root causes.
So let's talk strategy. What can be done? You mentioned 3 main categories.
Yes, let's break it down. Category 1 is all about lifestyle and nutrition. This is foundational. You really have to start here.
Makes sense. What's involved?
Well, first, the hard stops. Quitting smoking is non-negotiable. It has such a massive impact. And alcohol needs to be seriously limited. We're talking maybe 1 or 2 drinks a week, max.
Okay. And the heat avoidance stuff.
Absolutely crucial, and often easy wins, sort of low-hanging fruit. Ditch the tight underwear for boxers, avoid hot tubs, saunas, keep laptops off the lap. Simple changes, potentially big impact on scrotal temperature.
What about positive steps?
Yeah.
Exercise,
Diet.
diet.
Yes. Moderate, regular exercise, think 3 to 5 times a week, is great for overall circulation and health, which helps. Managing stress and ensuring you get enough sleep are also key, as they directly impact hormone levels and systemic stress.
And diet. You mentioned antioxidants earlier.
Diet is your internal defense force. Loading up on fruits, vegetables, whole grains, healthy fats like omega-3s found in fish. These foods are packed with natural antioxidants that fight those free radicals. This should be the base before even thinking about supplements.
Okay. And there was that surprising detail about frequency.
Ah, yes. Frequent ejaculation. It sounds a bit counterintuitive, maybe, but ejaculating every 2 to 3 days seems to help.
How?
It reduces the amount of time sperm spends sitting in storage in the epididymis, where they're vulnerable to accumulating oxidative damage. Basically, you're clearing out the older sperm and refreshing the supply more often, minimizing their exposure time.
Interesting. Okay, that's lifestyle. What's category 2?
Category 2 is medical and complementary care. This is for addressing specific underlying issues that lifestyle changes alone might not fix.
Like the varicocele you mentioned.
Exactly. If a significant varicocele is diagnosed, treating it often with a minor surgical procedure or embolization can dramatically improve DFI scores for many men by fixing the temperature and blood flow issues.
And infections.
Any identified infection in the reproductive tract needs to be treated promptly with antibiotics or appropriate medication to eliminate the source of inflammation and the resulting oxidative stress.
Makes sense. Then there's nutritional support, the supplement.
Yes. This is where targeted antioxidant therapy comes in. The sources consistently highlight a few key players with good evidence: vitamin C, vitamin E, zinc, selenium, coenzyme Q10.
CoQ10.
CoQ10, yes. Also L-carnitine and N-acetylcysteine, or NAC.
Are these just general multivitamins?
No, not really. They work synergistically, and some have specific roles. For example, CoQ10 and L-carnitine are vital for the mitochondria, the sperm's energy packs. Vitamin C and E are potent general antioxidants. Selenium and zinc are crucial for sperm structure and function. It's usually best when prescribed as a tailored combination based on individual needs, and importantly, alongside those lifestyle changes. They boost the foundation.
Okay. What about complementary approaches? You mentioned acupuncture.
Yes, things like acupuncture and sometimes specific herbal medicine protocols are mentioned. The idea is they may help improve blood flow to the testes, potentially reduce inflammation, and support hormonal balance, all of which can indirectly help combat oxidative stress.
Right. So lifestyle first, then medical fixes and targeted supplements, potentially complementary care. What's the third category?
Category 3 involves more advanced options. These are usually considered if SDF remains high despite trying the other approaches for several months. The main one here is using testicular sperm extraction, TESA, or TEAS for ICSI.
Taking sperm directly from the source.
Exactly. Retrieving sperm directly from the testicle before they travel through the epididymis and the rest of the reproductive tract where a lot of the damage can happen.
And this works because
Because sperm found in the testes often have significantly lower levels of DNA fragmentation compared to ejaculated sperm. They haven't had that long, potentially damaging journey. It's like getting the product straight off the assembly line before it sits in the warehouse. So using these testicular sperm for ICSI can sometimes improve outcomes when ejaculated sperm have high DFI.
that makes a lot of sense mechanically. Okay, one more crucial element you touched on, timing.
Oh, timing is absolutely critical. If we connect this to the bigger picture,
Yeah?
you have to respect the biology.
What do you mean?
The entire process of making sperm, from the very beginning stem cell stage to a fully mature sperm ready for ejaculation, takes roughly 3 to 4 months. About 74 days for spermatogenesis plus storage time.
So changes aren't instant.
Not at all. This means if you start antioxidant therapy or you have varicocele surgery, or you make major lifestyle changes like quitting smoking, you need to wait.
How long?
You need at least that 3 to 4 month window after starting the intervention before you plan a fertility procedure like IVF or ICSI. That's the time it takes for a whole new cohort of sperm, hopefully healthier sperm benefiting from your changes, to be produced and ready.
So rushing into an IVF cycle a month after starting vitamins is pointless.
Largely, yes. You're likely still using the sperm that were produced before the intervention took full effect. You need to time the treatment to coincide with the arrival of the new and improved sperm batch. Patience here is key to maximizing the chances of success.
That's a really vital piece of practical advice.
Oh,
Okay, let's try and synthesize this. So what does this all mean for you, our listener?
Yeah, what's the bottom line?
I think the core takeaway is pretty clear. Sperm DNA fragmentation, this hidden damage, can absolutely be a major reason for fertility struggles, like recurrent miscarriage or failed IVF, even if the basic sperm tests look normal. It's something that needs to be on the radar.
Definitely. It can be that silent antagonist, but, and this is the crucial but, the good news is that high SDF is often very manageable.
Right.
Through that combination approach, really focusing on lifestyle first, then adding targeted medical help or supplements if needed, and maybe considering advanced options like testates in specific cases, you can often significantly improve the situation.
And timing those interventions correctly with the sperm cycle.
Crucially, following these steps, being diligent, and giving it that proper time, it offers a real measurable way to improve embryo quality and boost the chances of a successful pregnancy.
Okay, great summary. As we wrap up, let's leave our listeners with a final thought to chew on, something building on what we've discussed. We've just spent a lot of time talking about how managing SDF successfully requires patients working with that 3 to 4 month sperm maturation cycle. You can't rush biology here. It kind of pushes back against our modern desire for instant result, doesn't it?
It really does.
So here's the question. If achieving success in this specific area of fertility demands, we respect this roughly 100-day biological timeline for interventions to work optimally, where else might we be fighting against natural rhythms? In other aspects of fertility planning, or even in managing other chronic health conditions, are we sometimes undermining our own efforts by expecting immediate fixes instead of planning for the longer-term cycles that biology actually operates on?
That's a powerful thought. Respecting the body's timelines.
Something to think about. We'll leave it there for this deep dive.